Hi and welcome. This time around I have an interesting project. It's a little different than the other ones I've done, although it's still for laser welding. It's a fixture that fits underneath a seam welder, which is a laser welder that welds along a seam. And in this case it's for tubes, and the bottom of the tube needs to be supported. So along the top is a mandrel that the two edges that are going to be joined together meet on, and then some fingers go down and hold those flat for the laser welder to weld along that seam. However, the bottom is not supported, and the tube diameters we're looking for are anywhere from 6" all the way up to 32", I think. And so we need to be able to slide that tube underneath and lift it to an appropriate height so that you can support the bottom of the tube while it's being welded so it doesn't go out of shape. Now, these two rolling racks I just ordered from MasterCar, and you'll notice that some of the rollers are out of place. Here. That's how they were delivered. I think that's kind of unusual. Basically, I'm going to take these two rolling conveyors, rolling gravity conveyors, I think they're technically called, and they're going to be mounted at 30 degrees to each other, so something like this and like this, forming a V, just like V blocks, except it'll allow you to roll tubing anywhere from 6" to 32", and they'll be mounted to a hydraulic table, a hydraulic lift table that will go up and down to support whatever diameter tube you're looking for. So I need to make brackets that hold the center part, two of them together 30 degrees, and support the outside at 30 degrees. To do that, we have some material here. So this bottom piece, we're going to cut this profile into. Holes are going to go this way to mount those brackets, and the bottom part will be flat. This is 1" tooling plate, and we're going to cut out the center section of this and then put 30-degree bevels on the inside, and it'll be mounted to the hydraulic plate along the center line. Although I will need to put a reference ball, at least I'm going to plan ahead, and drill and ream for a center ball to be mounted in the middle of this guy. These angle plates here are 1/2" thick aluminum, 8" angle plate. I need to take off a couple inches off the top of these guys, and they will be cut at a bevel 30 degrees, where they will support and meet the screws along the top of the roller conveyors, the gravity roller conveyors. So that top part will mount here, 3/4" bolts going through this material. Now, I wanted thicker material, but they didn't have it at the place I buy this from, and this is a prototype. So if this turns out to be too weak, which it seems like it shouldn't be, I mean, this is 1/2" material, thicker in the corner. If the 3/8" bolts that are every 5 inches are not enough, there'll be 5 of them in this. If that's not strong enough, then we can go to thicker material. I was originally using 1" tooling plate bolted to 1" tooling plate to do the same job. So the conveyor is going to mount here, like between here and here, like this, except this will be over a little further. And then this part actually hangs off the table. The table's only 18 inches wide. This guy will bolt to the table right along here. And there's about 5 inches overlap on the table. So we'll be inside here because there's some moving parts underneath the table that I can't interfere with, but I haven't gotten pictures of that yet. So anyways, we're going to start off working on the tooling plate. First thing I did was chamfer all the sides of the tooling plate with this chamfer tool. You can get these online. They're pretty fantastic, they're inexpensive, and they work surprisingly well. You've seen Max down in Australia use one of these, and I use it all the time. Highly recommend it. Works on steel or aluminum. This is aluminum, so it really goes easy and does not dull the blade. On steel, you get something like 60 feet before you have to replace blades. All right, so I've set up 2 vices here to hold this long piece of tooling plate. I could have mounted it directly to the table, but then I would have had to tram it in, and I would have had to space it up off the plate. So that would have been a big pain. It would have been just about as much work as moving both vices. And it turns out when I moved that vise, I have 5/8" pins sticking out the bottom because the Kurt DX2 vise has 5/8" pinholes in the bottom. And that lines up with my T-slots pretty well, and it usually gets it within a few thousandths. This one, it was dead on right off the bat, and then I just put this long bar in here the long way, and I clamped both vices on it, first that vise and then this vise, and tightened this one down, and it's within like 1/1000th or 1,000th or so over the whole 22 inches, so that'll be more than fine. So we're going to mount this tooling plate in both vices, and we're going to mill out the whole center section. And then we can also do the 8-inch angle plate also in the Kurt vices, because I think they hold better than 9 inches between jaws, and I only need 8. So I think we should be good there as well. Got the piece of tooling plate sitting in the parallels. I chamfered all the sides. I'm finding matching parallels. I don't have 2 sets of matching parallels, so I had to mix 1/4 inch thick and 1/8 inch parallels, and I compared them, and they were really, really close. I couldn't feel the difference with my fingers, so that means they're reasonably close. This isn't an ultra precision operation. If it was, then I'd probably need to take a couple sets of parallels over to the surface grinder and grind them all to be a match set, which would be useful. I've got some 1/2 inch parallels I think I should do that with, so that I've got completely matched sets, because this is not the first time I've used 2 vices, and I could see needing it again in the future. All right, so I use my electronic center finder, and here's some interesting little tidbits. One, I got this within a few tenths edge to edge for center. You know, I go to one side, hit 0, go to the other side, hit 1/2, come back to this side and compare the value. And it's within a few tenths that direction, the Y direction, about 7 or 8 tenths. Here's the interesting thing. This saw cut, this is just saw cut with like a table saw like device from my local metal supplier. The thickness is within 1/1000th along its length. I absolutely can't believe that their equipment's that dialed in for just material to sell to customers, get it that close within 1/1000th, over 22 inches, which is what this is. This is about 5 1/4. It's a little over 5 1/4 inches wide. I mean, what I need is 5 1/4, but in reality, the absolute width doesn't matter. I'm gonna do everything off the center line, so as long as I can find the center, I'll be good. I'm gonna be using a 3/4 inch zircon nitride coated solid carbide cutter with a 1 inch length of cut maximum, and we're going to use that just to do the 0.490 inches down the length. I'm using a Welder flat holder with the carbide bit all the way up. It doesn't have a Welder flat in it, which is not ideal, because that means the set screw is pushing against the shank, but it is carbide, so I haven't had a problem doing it in the past, and it's better than the R8s at holding end mills. I haven't had a suck out when I've used one of these yet, so seems like I should be able to take a 490 thousandths. Actually, I'm going to do 475 thousandths depth of cut, full width of a 3/4 inch cutter. Seems like I should be able to do that, right? So I cut it down to 1/10 of an inch depth, or 100 thousandths, and I sped the feed rate up a lot. It actually likes a much faster feed rate, which is really surprising to me. Still got some chatter, you can see on the bottom there. So I'm making really good progress. Hopefully when I do side cutting, I'll do climb milling on both sides. Hopefully that'll be better. This is not impressing me. Although I've had this problem with 3/4 and up end mills. 1 inch end mills are almost impossible to use. That's better. When it doesn't have to engage the, uh-oh. All right, so this should be fairly identical here to here and here to here, so I'm going to measure it in case something crazy like the entire top of the mill got pulled. The table shouldn't be pulled because the DRO is reading the same. So this here should be the same as this here. I'm glad I checked, because something dramatic has happened, and maybe the whole milling head got pulled. Maybe the whole head got pulled. I don't usually leave it super tight. I leave it snugged, but not super tight, because when that locked up the 3/4, it stalled the whole thing. And these are no longer, I'm no longer in the center, so I've got to find my center again. Oh boy, nice. All right, so we're going to try again. So to center this, the width, because I don't want to screw up my depth setting, what I've done is I found this thickness and this thickness, subtracted them, divided by 2, and moved the center by that distance. .7214. So 1.7216, 1.7214. So we're within a few tenths of each other, so our 0 is now good. So I got to figure out what my total deviation is, and we can get back to milling out the center section and then do the floor once we're done to the final depth. So we're doing 250 thousandths passes, and we go to a total of plus or minus 1.175. This ultimate thickness doesn't matter a whole lot. What'll end up is I'll have a 30-degree angle with a little flat where the 30-degree angle, if it continued, went higher than the thickness of this material. Oh, by the way, I never understand why people use air just to blow the chips out of the way when all that does is move your mess to somewhere else. If you use a vacuum, the chips are actually going in storage for you right where you want them. Seems like a better solution to me. My goal with the vacuum cleaner is just to prevent the cutter from running into chips that's already cut. Finishing pass floor and edge. 10 thousandths off the floor, 5 thousandths off the side. Climb milling on purpose for best finish. We are done. Spot base finish is really nice. All right, so next up, I got a drill and ream for a tooling ball in the center just in case I decide to mount this at 30 degrees. And if I decide to do that, then I have to make a 30-degree holding tool. So I don't think I'm gonna go that option, but just in case I decide to, I'm gonna have my dead center with the tooling ball here, which later will be drilled out and to 3/8 for a screw. However, the Master Car roller conveyors have some problems with them. One, they both arrived damaged, and I had to repair them, which is totally messed up, but considering they're twice as expensive as other alternatives. On top of that, they only have holes on the extreme ends, like all the way down on both sides. They're 5 feet long. This is going to be in the center. There are no mounting holes in the center at all. I'd have to drill those. Also, on the top of the conveyor, the top of the flange for the conveyor, there's no mounting holes there at all, and I need holes there as well. So there's cheaper versions from an American company that I think has their parts made in China. They have holes everywhere, and there are holes along the entire length of the bottom, but I don't know what the spacing is, so I have to hold off because the holes here need to match that spacing. So, oh, actually, no, these holes don't. These holes are to mount into the hydraulic lift plate, lift table. So actually, I can put these anywhere I want. I can go ahead and drill these out now. Oh, okay, perfect fit. Good snug fit. Okay, so this tooling ball can be used when I go at an angle as a reference point because anywhere I touch on the outside will be equidistant from the center line of the, well, the center point of the sphere, which is really useful. Typically, I'm lazy. I don't use trig to figure it out. I lay it out in CAD, and that lets me find my spot. These are the screws I plan on using, some low profile 3/8 screws. All right, so next up we got the angle plates in here. This is more flat work. This is a bit pedestrian, 3 holes in this plate, 3/8, not a super precision operation either. I'm thinking I'm gonna bandsaw off most of the height on this, since I gotta take off 1.5 inches. So I'm going to bandsaw like 1 3/4 or 1 1/4 rather, and then I'll take a milling cutter and remove the rest. So I ran across a peculiar problem here. I wanted to mark my line where to cut with the saw, and I mean I have this problem because there's a radius here. I don't know if you can see that, but there's a nice tidy radius at the end. So the Starrett, it won't reliably line up with that. So I ended up having to use a woodworking tool for marking and putting a scribe line down this. It's crazy what you got to resort to, right? You can probably just barely see this. This is the world's stubbiest 3/4 inch end mill. I think it's got half inch length of cut, but we're just going to use it as a face mill to run along this edge here. And I think we're going to start by just taking off a short cut so I can get a good measurement. And then we will come back and get this to final dimension, which is 6.5. Actually, it's 6.490, I believe, but very close. Next up, I'm doing the second one here, and to add some stiffness, I've clamped this 1/2 inch plate in the vise on the bottom and cant twist clamps along the top. And we'll see how that works if I can take a bigger depth of cut this way. Much better so far, even though my bite is significantly more in some spots. This is more than 1/10 of an inch depth of cut. Okay, so where it's not clamped in the middle, it's getting a little funky, so I'm holding it, dampening it with my hand. My vacuum is still sucking. I'm not sure why, because the filter was buried all the way in there. And it started to go down, and I was trying to figure out why. Now you know. Well, we're back here again. I had to change the height of this because I chose different gravity conveyor rollers system, so they looked identical, and the outside dimensions 5 foot by 1 foot with 10-inch rollers, all identical, but hole placement, everything else is slightly different, just enough that it's not compatible. Figures, right? And on top of that, I discovered that this piece of angle here is warped, so it doesn't sit flat. See this? So when I cut it the first time, I didn't realize that. And I'm off by 40 thousandths on one side, which for me is way too much. Probably in the scale of a project like this where there's no real precision required, it's probably okay. But what I'm going to try and do is I'm going to try and clamp the back down flat to the base of the vise to keep it, try and force it square, try and actually bend it into square. I don't know if I can do that. We will see. So last time I just clamped this for some additional support of thickness on the top. I decided I'm going to machine this flat at the same time. I could have lifted it up a little bit, but we're not going to do that. So we got a bit of a challenge ahead of us. This is pretty thick material and pretty stiff, especially with the bend right here. I don't know that I can pull this straight. It's amazing that it's off by as much as it is. But I guess they never promise precision in this sort of material. One thing that I should keep in the back of my mind is if you ever do something like this and you're trying to do real precision work, this could cup my ways of the mill here. It could cup it like this because it could push, well, actually cup it like this. It could pull this side down. Well, I guess it depends on which stronger. If this plate is stronger or the ways are stronger. If this is stronger, then it's going to bend like this. And if the ways are stronger, they're going to cup a little bit like this. As this side, there's a lot more force here than in the middle. It will cause it to cup, and so if you're shooting for tenths or maybe even thousandths in the case of some examples, you've got to be very careful about how you clamp, and it'd be better to clamp from the vise to the part rather than to the mill table like I am here. So I got to be careful with that. Doing much better this time, of course. Once I remove these clamps, it's going to spring back. However, this angle plate is also being clamped to the table it's going on, so that might straighten it out, although this is thicker than the material. It's all like 10 gauge material on the lift table. This is going to get bolted to, so not perfect. So I'm setting knotting the head to 30 degrees, which is more than I've ever knotted it before. It's really seems like this would be too much, but anyways. So I've got a 30-degree angle block. So the markings on the side of my mill say this is about 28.5, but when I put an angle block against this backing plate here, that's really, really good. I mean, it's not perfect, but it's really close. So let me show you what I did. I did a model of the end of this after it's been cut. The dotted line there is before it's been cut. So I can, and here is the cutter right here. This is a 3/4 inch cutter. So I've modeled that as well. And what I can do is I can use my y-axis and pull the cutter off the part, which takes, you notice this thing, because it's sloped, this is higher up than this physically. So if I move it in my y-axis, that will keep the cutter off the part, and I can just remove a little bit of material initially and then move in progressively with the y-axis to get there. So I can bring my z-axis up 0.264, and then if I'd wanted, I could calculate from the edge of my cutter in with the Y motion. I could have calculated that as well with CAD. When I'm done, I should have a flat that's like 42 thousandths wide, roughly, based on these dimensions. So let's give this a shot here. I think we're going to do the Z-axis because trying to plunge accurately is harder with the quill, I think. I mean, I could do that too. I've got that measurement here. Here's the quill plunge right here now that we're lined up, 0.2287. But then if I move anything in the y-axis, it'll take more or less material off. So I think we're going to avoid that. All right, in case what I said was confusing before, you see how the cutter's just overlapping the edge right now? As I move the y-axis in, the lower part of the cutter is intersecting with this, and it could take more and more material. So if you see what I'm saying, then I can just walk this in my y-axis. That was a 25 thousandths move on the y-axis, which obviously did not translate to anywhere near as big a vertical change. So I can do bigger bites. We'll come back again, do a bigger bite. All this flat spot is a resting point for the bottom of the gravity conveyor. All right, we're set up with number 2, and sure enough, this end down here had sprung up a lot. Until I clamped it down and pulled it down, it wasn't flush down here. It was off by about 40 thousandths again, so we're not actually straightening it, which means when I actually put it on the cart, it's going to be off by 40 thousandths. Maybe the top will pull it down 10 or 20 thousandths. I mean, this is not precision stuff. It's just, it bugs me when things aren't perfect. But anyways, we're going to do this one. We're going to trim this one, and that finishes number 2. Now for the interesting challenge. I need to drill this at this 30-degree angle. I can lower the table, and I guess I can take the ram and stick it way out this direction. I can take the ram and move it this direction a bunch. I'm going to kind of need to get anything like a drill chuck in there. Wow. Maybe we're going to have to take the tapping drill and put it in a collet instead of a drill chuck. All right, so next up we're going to drill holes, but I need to find obviously my X coordinate center, and then all the holes are built off the center. That way the ultimate absolute length of these doesn't matter. I have a stop here, so when I take this one out and put the next one in, I can just go. Got to make sure to keep it tight, but this is very rigid. They did a good job with that. Still got to clamp down on the bottom because there's twist in both of these that makes one part higher than the other. So if I want the holes to be the same, then I have to clamp it down. And originally I want to do 3/8 holes, but there's not very much meat if I do 3/8 holes. So I think I'm going to go do 1/4 holes, and we'll start with that. I can always make them larger later. Without normal datum points to pull from, I had to pick something like this corner, which isn't even a 90-degree corner. It's greater than 90 degrees, so it's very hard to get this lined up. But I've got the point of this guy in the drill chuck here, and this is how I'm setting my 0. And then I will move horizontally. I'll lift this up and I'll move over horizontally to where the center is based on trigonometric calculations done by my CAD software. I could have done them manually, but I chose to do them this way instead. And then we'll drill the holes. However, I realize there's really, even with this retracted all the way, like it is now, there's not enough room to get my drill bit in and out and the tap in and out. So I got to drop this down, which means all of that, because this mill, its XYZ planes are not in the same plane as this 30-degree plane. So motion is not the same. So it'll screw up all my adjustments if I don't take that into account. Sort of did a mock-up here. So here's the center point right on that corner. Here's the center point dead center where the hole should be. This is the horizontal distance with my actual mill y-axis. In the plane of this cut, the y-axis would be here and you'd move this way, but I can't do that. I move this way. So the distance is not the center, the thickness, it's actually longer than thickness, 0.2971. So if I go over 0.2971, when I drop this guy back down, that should be center, and that very much looks to be the center. There's the first hole done. I didn't show a lot because I wasn't sure if I'd gotten it quite right. I only designed this with, initially with, there's hole spacing every 3 inches on the conveyor panels, but I originally did it at center 9 inches and 9 inches, which probably is enough. But just in case, I'm going to go every 3 inches and I can populate them or not. And I know I didn't show you that, so we're going to go over 3 inches. If this thing's shifting on me, this would not line up, but it does. I'm going to check each one. All right, there's the first part done. I'm gonna do the second one. I'll bring you back for the other piece, which is gonna get interesting.